So let us talk about circular motion. Specifically, we're going to talk about centripetal force. So a ball is rotated or whistled at the end of the string in a horizontal circle 50 centimeters in radius, okay, at the rate of one revolution in every 2 seconds. So when you hear in every 2 seconds, that is the period. So the period is that, okay. And then another thing that we have to know is that we have been given the radius. So it is 50 centimeters. If I divide it by 100, it will be 0.5 meters. And we know that what is happening here is you have got a ball that is being rotated, okay. So we know that the centripetal force is directed in that toward the center. That is the same as centripetal acceleration. Centripetal acceleration is given by v squared divided by r. I have my r, but how can I find the v? If something is rotating around the circle, then this is true. V is equal to distance divided by time. The distance covered from one revolution from this point until it comes back to that point is the circumference of the circle. Circumference of the circle is 2 pi r. I divide that by the time it takes to complete one cycle. We've been told here that is the period, that is t. So I can find, okay, I can find now the v. If I want direct from here, then I come back and plug in the value. Or if I want, I can just plug in this formula with what I have on v. Say AC is equal to, I'll plug in 2 pi r, then I divide this by t. So this divided now is for this r. I'll put it here. But this is squared. Everything is squared. Then the centripetal acceleration is now, if I square 2 is 4, pi will be pi squared, this will be r squared divided by t squared. Then I can do this times 1 over r. So 1 r can go and I can remain with 1 r. So AC will be equal to 4 pi squared r divided by t squared. Now you can plug in the values, okay. You can plug in the values. So AC will be equal to 4 pi squared, the r is 0.5, the t is 2, but I square it. So what answer are we going to find? The centripetal acceleration, okay, the centripetal acceleration is going to be, so it's going to be like this. We have 4. So get your calculator and try to punch, okay. So we have 4 times pi squared times 0 0.5. I divide this by 2 squared, which is 4. So the answer I'm getting is 4.9. So this 4.9 is 4.93. If I want, I can say it's 5, but I'll just leave it like that. I'll say it is 4.93 meters per second squared. So the SI unit for centripetal acceleration is meter per second squared. Now In a case where you're having difficulties on how to do this using that formula, what you can do is, let me just leave it here. What you can do, you can, when you come up with this formula, you have v squared divided by r. So you can find first v, 2 pi times 0.5 divided by the period is 2. So what will be the v? So it will be 2 pi times 0.5, okay, then divided by 2, that is 1.57. So 1.57, it is meters per second. Then you come here and plug in the value. So 1.57 squared divided by 0.5. So AC will be equal to, if I square this, it's giving me 2.467 divided by 0.5, and there we go. You'll be able to have 4.93 meters per second, like that, or squared, because it's acceleration. So that is it for this question.